Coagulation by addition of electrolyte. The reason is colloids interact with the ions carrying charge opposite to that present on themselves. This causes the neutralization of the charge on colloidal particle and causes coagulation. The neutralization of charge results in interaction among the differently colored colloidal particles, and they adhere together or fuse together to make precipitate. Now, the coagulating power of an ion is decided by a rule known as the Schulze Rule. This Schulze Rule counts the coagulation power of any ion based on their charge, which is opposite to the charge on the soul. For example, in coagulation of negatively charged soul, flocculating power or coagulating power depends upon the charge on the ions, and in the same corresponding order they are arranged. For example, aluminium having a 3 positive charge having a higher flocculating power than barium 2 positive ions, in turn having a greater flocculating power, sodium ions. Similarly, for coagulation of positively charged soul, we use negatively charged ion, and hexasign of ferrite 2 having a greater flocculating power than phosphate, having a greater flocculating power than sulfate, in turn having a greater flocculating power of chloride ions. This is the order of arrangement for flocculating power of our negatively charged anions for positively charged souls. For coagulation, the minimum concentration of electrolyte required in millimoles per liter to cause precipitation of a soul in 2 hours is called as coagulating value. So definition of coagulating value is the amount of millimoles per liter required to cause precipitation in 2 hours. 2 hours is a time period. Concentration in millimoles per liter, the volume required. Smaller is the quantity required, higher will be the coagulating power of the ion, as we saw Schulze Rule. Factors such as charge and solvation of the colloidal particles decides the stability of colloid. When these two factors are removed, lyophilic souls can be coagulated. So far we had talked about only our lyophobic souls, but even lyophilic colloidal solutions can be coagulated by addition of an electrolyte, by adding a suitable solvent. When solvents such as alcohol and acetone are added to hydrophilic souls, a dehydration of dispersed phase or colloidal particles occur. Under these conditions, small quantity of electrolyte can bring coagulation. Another is protective power of colloids. Protective power means to what extent colloidal solutions can remain stable. It is measured through Gold number, which is used to define protective power of colloid. Gold number is defined in colloidal chemistry. It is the minimum minimum amount of protective colloid in milligrams which prevent a color change from red to violet of 10 ml of gold salt by the addition of 1 ml of 10% sodium chloride solution. So we use a protecting power as a gold number. The amount of protective colloid, the protective colloids are the solution that are used to protect colloidal solutions from precipitation or coagulation. The minimum amount required to prevent coagulation in milligrams, which prevent the color change of gold salt, which is 10 ml, and we are adding 1 ml of 10% sodium chloride, which is nothing but is electrolyte or coagulating solution. Further, we are having another liquid in liquid colloidal solution known as emulsion. When a mixture of two immiscible or partially immiscible liquids, remember, emulsions are made out of partially or fully immiscible liquids. When we shake them, a coarse dispersion of one liquid in another is obtained, which is called emulsion. So emulsion is a colloidal solution of two partially or fully immiscible liquids. Two types are possible: oil dispersed in water and water dispersed in oil. Means oil is a dispersed phase, water is a dispersion medium. Here, water is a dispersed phase, oil is a dispersion medium. These two are the emulsions possible. First, oil dispersed in water. Emulsions of oil water are unstable and they separate into two layers because of oil is lighter, it comes up. To stabilize such emulsions, we are using an agent known as emulsifying agent. They prevent the separation of two layers. Milk and vanishing cream are examples of oil in water emulsion. The emulsifying agent forms an interfacial film between suspended particles and medium. Emulsifiers having a hydrophobic and hydrophilic ends, just like surfactant we saw. Cleaning agent of surfactants or our soaps we saw, they are just like same only. They got two different ends. One will go to oil or dispersed phase, other will go to water, hydrophilic medium. Phospholipids and fat-soluble phosphates are acting as the emulsifying agent in milk. Next is water dispersed in oil. Butter and creams are example of such medium. Same thing acts here. We are having a certain emulsifying agent that prevent the, we can say, coagulation or separation of two media. Like in egg yolk, lecithin acts as our emulsifying agent.